In the past few decades, we have seen robot technology go from lumbering behemoths that could barely move to nimble contraptions that can do backflips and dance. It takes a lot of effort to teach robots how to move. Therefore, researchers are increasingly relying on the AI to do the heavy lifting for them, and a team of researchers at MIT has come up with speedy results. A mini cheetah robot designed by them has set a new personal best movement speed using learning algorithms which ensure it learns from every fall. So, let's talk about it. Hi and welcome to AI World News. Today we'll be speaking about how fast the mini cheetah robot can go. Please watch the video to find out all the details and don't forget to like, share, subscribe and click the bell notification. Robotic animals are becoming increasingly sophisticated. Mimicking the form and functions of creatures, ranging from birds to llamas, robotic animals can perform backflips, navigate treacherous terrain, and right themselves when they stumble, not to mention the softer features, like providing emotional support for the elderly. But robots have long struggled to mimic real-life animals in one fundamental locomotive ability: running. The main difficulty lies in equipping robots with the ability to maintain high speeds, while running across different types of tricky terrain. Unlike animals, most robots don't automatically adjust their gait when moving from, say, grass to ice. Horses gallop, kangaroos hop, ducks waddle, elephants amble. The fleet-footed quadruped robot called mini cheetah, well, doesn't move like anything in the animal kingdom. A cross between a scramble and a scamper, its gait is desperately chaotic and comically ungraceful. In fact, its particular style is dubbed gait-free, and this brand less bound is what makes it fast. Capable of reaching the speed of 70 miles per hour, a cheetah can be the fastest sprinter on land. And now a newly revamped robot from MIT called the mini cheetah is vying to be among the fastest technologies of its kind when it comes to running. And all the credit for it goes to artificial intelligence. Not only can the mini cheetah cover more than 12 feet in 1 second, the dog-sized robot can also learn to adapt to different terrains and respond appropriately to its environment. What we are interested in is, given the robotic hardware, how fast can a robot go? Says Pulkit Agrawal, an AI researcher at MIT and the leader of the improbable AI lab that conceived the project. We didn't want to constrain the robot in arbitrary ways. Previous top robot runners were only speedy in limited scenarios. They performed best on an indoor treadmill, but suffered when navigating uneven terrains in the real world. Conversely, robots that could cross any kind of topography were generally sluggish across the board, because they weren't optimized for speed. Their responses were challenging to program. Mini cheetah has the best of both worlds. Traditionally, programming a swift robot requires engineers to preemptively work out all the possible variables in the environment that could be a drag, such as friction. Then they would have to wire in all the commands for every possible rundown and analyze the errors the robot made afterwards. This process involves the robot running many real-world trials, because engineers can't account for all unknowns in all settings beforehand. So, most of the robots you've seen placidly walking around on level surfaces have been programmed to do that. The same goes for Boston Dynamics with all its fancy robot demo videos. Programmers have written code that tells the robots how to move in order to walk, jump, or do a backflip. However, you can't account for every possible situation or surface, even with an army of programmers. Therefore, neural network can be used to leverage a robot's experience, something we biological organisms do all the time. In simple words, after years of walking on uneven surfaces, your brain knows what to do if you lose traction. You might not only save yourself from a tumble, but you can learn and adjust your behavior next time. The MIT team managed something similar for the mini cheetah using AI and modern simulation tools. The robot can gain 100 days' worth of experience in just 3 hours of actual time. Through trial and error, the robot gets better at navigating the world, and no one has to explicitly tell it how to do that. The MIT researchers' workaround was to use reinforcement learning, a goal-driven form of machine learning, to help a robot like mini cheetah figure out how to reach its top speed on its own. First, the team simulated all the potential scenarios of the real world in a computer. Then they trained mini cheetah's software on these virtual simulations before its deployment. Schooled on this dataset and free of any programming constraints, mini cheetah is able to create its own signature sprinting style that humans wouldn't have been able to conceive of. Furthermore, it could modify how it loped in real time to adapt to the conditions of its route. In addition to boosting speed, the method enables the bot to learn other locomotive abilities, like moving efficiently with a disabled leg. What's more, the quadruped can learn through experiences not only on real-world terrain, but also on simulated terrain. So using simulation tools, the team trained the robot to navigate different types of terrain within simulated environments. The model is something like a sped-up version of how humans and other animals learn to navigate their environment, through repeated trial and error. Thanks to this machine learning software, Mini Cheetah bumped its peak indoor velocity from 12 feet per second, before training to 13 feet per second after. It more or less maintained this speed outdoors when tearing up unfamiliar grounds. In addition, it could catch itself when it tripped, and even if it had a broken leg, it could find a way to hobble on at maximum speed. Agrawal says that hardware upgrades will be necessary for Mini Cheetah to go even faster. For example, its engineers can give it a more powerful motor or even include an ankle-equivalent joint in each of its limbs, which can in theory bump up its speed even more. Other hardware enhancements that can boost Mini Cheetah's agility and responsiveness include incorporating sensory elements such as vision, so the robot can literally look before it leaps and switch up its running behavior in advance when it spots a rough patch ahead. This may allow Mini Cheetah to stay swift on challenging terrains. So, it's not the fastest robot on record, but it is the fastest robot that uses such a learning-based approach and this specific robotic platform. Other, larger robots have run faster, even some of those built at MIT, including a previous high-speed record set by another MIT research group. However, these previous running robots are analytically designed, meaning they rely heavily on human engineers to anticipate obstacles and program locomotion in response to them. The Mini Cheetah, on the other hand, is a learn-by-experience mode that uses a simple neural network, which allows it to respond in real time to environmental challenges. This newly designed method allows the robot to learn how to run fast while also adapting to walking on difficult terrain, which could show a new capability for robots in the future that might also employ the learning-based method. This adaptability is thanks to a simple neural network that can make assessments of new situations that may put its hardware under high stress. To be clear, the team isn't gunning for the world's fastest automaton. Instead, the researchers aim to democratize sprinting for any run-of-the-mill robot. The cool thing is that you could apply this algorithm to any robot, and it could also very likely maximize the speed on that robotic platform, says Agrawal, because we're not making any specific assumptions about that robot. The researchers are also planning to make their computer code open source really soon. Then, every robot may be able to reach its full running potential. Only the hardware is the limit. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comment section below. Don't forget to like this video, subscribe to our channel, and ring the notification bell. And thank you for watching.